Hi, this is Eric White. This is the third screencast in this series on writing recursive pure functional transformations. In this screencast, I'm going to continue looking at the primary usage scenario for functional programming, which is transformations. And more specifically, we are going to continue examining the various operators. In other words, the various methods that enable us to write interesting queries. In this screencast, we're going to look at the sorting, the grouping, and aggregation operators. Another operator that is interesting is sorting. We certainly will have occasion when we will need to sort data. Let's take a look at the changes to our small example program that enable us to do sorting. In our C# example, let's just change it to order by as opposed to where. And I'm going to change this example so that instead of returning a value I times 2, or instead of returning a value I is greater than or equal to 4, it's just going to return I. In other words, this is a lambda expression that tells the order by operator what is the value that should be used for ordering. So for instance, we might have a large collection of objects, and these objects have lots of different fields in those objects, but there's one particular field that we're interested in when we are wanting to order that collection. And so what we would do is we would return that particular field or that particular property in this lambda expression that we pass to the order by operator. And if we run it, we can see that in fact it does return those set of integers now ordered ascending. Now let's look at the same modification to the JavaScript version of this example. And as you can guess, I modify it to call order by. And instead of returning I is greater than or equal to 4, we just return I. And we run it and we get the exact same results. And now I'm going to show something that's interesting. It's a little more interesting. It's a little more complicated. And this is the idea of grouping. Let's go back to our C# application. And instead of having this be a collection of integers, I'm going to modify this to be a collection of tuples or a collection of anonymous types, and then I'm going to write code to group them in a certain way. So now I'm going to make one person named Bob who's age 50, one person whose name is Bill whose age is 40, another person Cheryl, and she is also 50, and Jill is 40, and Frank is 30, and Cindy is also 30. This is obviously artificially made very simple, but that's okay. This will serve to illustrate the point that I'm trying to make. Now let's take this query, and instead of saying order by, I'm going to say .group by, and I'm not going to group by the I. Instead, I'm going to group by I.age. Now, the next thing that I have to do is I have to modify this code that iterates through the results, because instead of returning a collection, when I group something, it actually returns a collection of collections. So let's look at what that looks like. In this collection of collections, I'm also going to modify this. I don't want to send this to an array. I just want to deal with collection because that's more appropriate for dealing with groups. So I'm going to do for each G or GR in result. So each one of these GRs is a group in the collection of groups. Let's look at the key of this group. So we look at gr.key. Let's also look at the count of the number of members in each group. And now let's do another for each. I'll for each item in GR, and I will now print out that item. I'll print out the item.name and the item.age. And after we have printed everything about that group, let's just print a blank line so that we get a blank line between our groups so that we can see what we have. And we're done with our code. Let's run it. And we can see here, first we have a collection of items where the key is 50. And we can see that this collection has 2 items in it. And Bob is 50 and Cheryl is 50. And of course we can see that we have a collection of items where the key is 40 and there are 2 items, and Bill and Jill are both 40. And we can see the final collection where the age is 30. This idea of writing a query that results in a hierarchical result set is a very interesting one and very crucial in a lot of scenarios when we're writing complicated transforms. And we can go and see the exact same code in JavaScript now. There, we've made the corresponding changes to the JavaScript example. So let's run it. And we can see that our result is identical to the result that we had in C#. We had to make a fair number of small syntactical changes, such as changing the casing of the various methods. In JavaScript, we use a lower camel case convention for these method names, whereas in C# it uses an upper camel case method, and so on and so forth. But nevertheless, you can see that logically the exact same code works in JavaScript and in C#. The last operator that we're going to examine in this screencast is that of aggregation. Aggregation is the process of taking an entire collection and returning a singleton, or returning a single value from that collection. The simplest aggregation operator that we can use is, for instance, the sum operator. This simply takes every item in the collection, sums them together, and returns a single value, a single integer. And so if I run it, I get 23, which is the sum of all of those integers. I could see what the average of those values is, and it's 3.83. But something that's interesting is that instead of using sum or average, there is an aggregate operator that we can use to handcraft our aggregation. So let's tell it to aggregate. I am going to tell it that I want to start with the seed of 0. And what the seed of 0 means is that this is the first value that gets passed into the aggregation. And then for every item in the aggregation, I am going to pass a lambda expression. This lambda expression takes 2 arguments. The first argument is the seed, or the previous value in the aggregation. And the second argument, this I argument, is the value of that member in the source collection. So when I run this code does exactly the same thing as the sum operator. It's just a handcrafted sum using the aggregate operator. And something else that we could do is we could change all of these to strings. Now, as we know, in C#, adding 2 strings together concatenates them. I also, for a seed, I should pass in the empty string. And now when I run this example, instead of aggregating a number of integers and coming up with the sum of the integers, it's going to aggregate a set of strings and give us the concatenated set of strings. And we get a string that has 314159. So concatenation is another aggregation operator. Let's look at the same example in JavaScript. And let's run our little example in JavaScript. And in fact, we get the expected result, which is 23. The sum operator works exactly the same way as the sum operator in C#. If you want to see that, I'll leave that as an exercise for you. And we can also do the exact same experiment, changing these all to strings as opposed to integers. And we can run our example. And we get the same result. So let's talk a minute about what's in common with functional programming and object-oriented programming. Well, you can still define classes in functional programming, but there's a key difference. Once you've instantiated the class, the data is immutable. That means you never go back and change values in an instance of a class. If you want a new object that has different values, then you new up a new object. You don't modify an existing object. And this will become clear as to why we do this when we get into the idea of pureness or pure functional programming, and that will be in another couple of screencasts. You can still write methods in your classes if you want to, but primarily the emphasis is on static methods as opposed to methods that operate on a particular instance of the class. It doesn't really matter. You can put a method on an instance of a class that operates on data of that class if you want to have a method that returns a particular value based on data in the class, on that data that is immutable. You can write procedural code in your methods, but a key point about this is that you don't change data outside of your function. Well, that's enough to cover in this screencast. In the next screencast, we're going to delve into those interesting things, lambda expressions, in quite a bit more detail. Until next time.